Hello there, children. Today we are going to work on section 2.5, Rational Functions. Fall themed indeed, I know. This educational experience is brought to you by your real friend of rational functions. That'll be me, Mr. Faust. Alright, so we're going to deal with the very basics today of graphing rational functions. There's a lot more to this than what we're going to cover today, but we just need to get the bare bones of what we are going to be doing in the future. So let's begin. Alright, so we have a couple rules here. Alright, here are some tips for graphing. Now, these aren't the only tips we're going to have, but they're the start of what we're going to be doing. So, first step is find the y-intercept, if there is any. Now, to find the y-intercept, you set x equal to 0 throughout the problem. Now, there might not be a y-intercept. If there's not, that means you know your graph does not cross the y-axis at all. That'll be helpful for us. That means set x equals 0 and find that. Then, set the numerator equal to 0 and solve. Numerator polynomial. Now again, this is in the form, in case you were curious, of the following. Some polynomial that is numerator polynomial over denominator polynomial. So you set the numerator equal to 0. That will give you the x-intercept. Remember, because you set y equal to 0, which would cross out that bottom polynomial. Then, set the denominator equal to 0. That's step 3. Now this one is very important to us. This will give us our vertical asymptotes. Vertical asymptotes are our MC Hammer of mathematics. We cannot touch them or cross them. So, remember, why is it an asymptote? It will give us our vertical asymptotes if provided we haven't canceled out with my numerator. So, when you do this stuff, you want to factor everything and then set my denominator equal to 0. Step 4, find the horizontal asymptotes. Now, there's a fun little acronym for horizontal asymptotes. That would be the following. Bobo, Botten, capital T, eats DC. Now, what in the world is that? Ready? If our asymptote is, ready, bigger on bottom, it's y equals 0. Bobo. If it's bigger on top, none. That means we have no horizontal asymptote. Exponents are the same, eats. You divide the coefficient. Now, I know this is a lot to take in, so let's process this for a second. We look at our biggest exponent of the numerator and my denominator. And I go, okay, is the numerator exponent bigger? If it's bigger on top, I have no horizontal asymptote. If the exponent is bigger on the bottom, my asymptote is y equals 0. And if exponents are the same, I divide my coefficients. So that's a good thing for us. Then, I plot at least one point, besides my intercepts I already have, between the vertical asymptotes. So that means you need to create a t-chart as best as you can with many points. Now, you want to pick them in between here because you don't want to pick points that are my asymptotes, obviously, and you don't want to pick points that are intercepts you already have. So you want to create some values that aren't those so you can get a better picture. And lastly, use smooth curves to complete the graph. So, there's a lot to take in, so let's go through the process here. Alright, so let's look at this particular function. F of x equals 1 over x. So, I've got some rules. Step 1, you set x equal to 0. That means I get 1 over 0. Can that happen? Why, sure as shooting, it cannot happen. So, is there going to be a y-intercept? No. That means this graph is not going to cross my y-axis. Step 2 is you set the numerator equal to 0. Well, does 1 equal 0 here? No, it doesn't. If you think it does, I will give you $0 if you give me $1. Yes, so there is also no x-intercept. Okay, that's wonderful. Now, what's my third step? Well, the third step is once this whole thing is fully factored, I set the denominator equal to 0. Well, that's fairly simple. It means x equals 0. That is my vertical asymptote. Now, notice it's on my coordinate axis here, but I'm just going to dot the line for you. You don't have to do this, but just so you're aware for right now. Okay. Now, fourth step. That would be my wonderful and glorious Bobo-Botten HDC. Look at my exponent. Now, you're like, but there's no x up here. Well, there kind of is an x up there. We just don't recognize it because it's an x to the 0 power. We don't need to write it because it's kind of pointless, but just for right now, I'm just showing you what it means. And that's an x to the first on the bottom. Where's my exponent? Are my exponent the same? No, that's a 0, that's a 1. Is it bigger on top? Bottom? No, that's a 0, that's a 1. Is the exponent bigger on the bottom? Why, yes it is. That's a 1 on the bottom, that's a 0 exponent up top. I'm only concerned about the powers of x. So that brings me to a Bobo, or bigger on bottom situation, which means y would equal 0 there. Now, you're wondering, how the heck does this work? Think logically. As I put bigger and bigger values of x in here, like 10 million, 20 million, things of that nature, the bottom, because the exponent is bigger, is going to grow much faster than my top. If the bottom grows bigger, that means I have a bigger denominator of my fraction, which means the fraction gets smaller and smaller, closer to 0. If the top were bigger, the fraction would grow and grow and grow and never be limited by an asymptote. If the exponents are the same, that means they would grow at the same rate, top and bottom, as my x's got bigger. So then I would just look at my coefficients. Now, step 5. I plot some x values here. Now, realize something. I'm just going to pick some simple ones. Now, you have to realize something. 9 times out of 10, that should be an x equals 2. These asymptotes don't get crossed. We are going to run into some situations this year that we do cross asymptotes for a second, but we will talk about them at great length. So, putting this in here. Now we plot these points. Now, what's great is, as I go further and further out towards infinity and beyond, get the pun there, this graph will become asymptotically close to my line. That means it gets close like an asymptote. I don't cross my line there. In here I could do some funky things. Maybe I cross at some points. You never know. But as I move further out here, it gets close to my asymptote. Same with this. It's not going to cross ever. It's just going to get really close. And up here, it's going to grow. Why is it going to grow towards infinity like that? Think about it. These numbers are really tiny, like 0.1. Divide 1 by 0.1, you get 10. Divide 1 by 0.001, you get 100. And then so on and so forth. This value is going to grow. Same way over here, just a negative version. So, let's move on to another fun example here. Okay, so let's look here. I am going to graph this particular function. Now, before I start out this wonderful thing, I do want to factor this. Now, you should get in the habit of factoring everything. Why is that? Because maybe at some points, what we're going to find is stuff will cancel. We're not going to get into that in this particular video, but we will talk about what happens. Now, you should know how to factor that. So, let's go through. Step 1, find the y-intercept. That means set x equal to 0. Okay, Well, hey, look at that. I get 1 over negative 1/4. That's my y-intercept. Okay, that's a smidge right there. Graph that thing. Boom. Now, step 2. Set the numerator equal to 0. Last time I checked again. Nope, that can't happen. So there is no x-intercept. Does not cross the x-axis. Step 3. Once factored, I set my denominator is equal to 0. As long as nothing canceled, and nothing does here. We get x equal to 2, x equal to negative 2. Those are my wonderful and glorious vertical asymptotes. Step 4. We look at our wonderful and glorious Bobo bot in ETC. My exponents on the bottom are clearly bigger. There's an x to the squared there down here, and there is no x squared up top. So that's a Bobo situation. That means y equals 0 for my asymptote. Now you pick some points. I'm going to pick some points in the middle here. I'm going to pick, I don't know, x equals negative 1 and x equals 1. I'm going to pick x equals 2. No. Why wouldn't I do that this time? Well, that's an asymptote. So I move over and pick x equals 3 and x equals negative 3. And I go from there. Now you could obviously pick more points using a t-chart. So we fill out these values. And when we do that, we find the following. I get negative 1/3. Now it's 1 over negative 3, but I put the negative up top, folks. Hope you don't mind. Negative 1/3. Then I get the following. Y equals 1/5. And y also equals 1/5. So let's look here. I get negative 1/3 down here, which is slightly lower than this 1/4 that I had, and slightly lower. Up here, I get 1/5 and 1/5. Now, what's great is I know what shape this is going to make. It hugs my asymptotes. Remember, we talked about that. It hugs my asymptotes out here. Now, you could prove that by picking more and more values there, if you still felt the need to do so. Now here, what's great about being in the middle here, the middle of these two things, it predominantly makes two shapes, either a cubic or a quadratic. As you see here, there's a point, and it's going down either direction like that. It makes a quadratic looking thing. Now, let's talk a minute about domain and range again. Domain. What are all my possible x values? Well, what can't I have here for x's? I can't have values of negative 2 and 2 there, can I? No. Those are pretty simple. When you have vertical asymptotes, those, generally speaking, are my domain. 99 times out of 100. Now, the horizontal asymptotes are a little different. What are my y values? Well, look, I go from pretty much 0 to infinity here. So if I'm running out my range here, just for posterity's sake, one of my loops is going to be from 0 to infinity. Notice my open parenthesis at 0 here because I can't have that. I'm not going to be able to touch my asymptote on this graph. We will have ones that do cross, don't worry, but for right now I don't. Now, I go from also negative infinity all the way up to 1 point. It's not 0 in this case. It's what? It's the following. It's negative 1/4, the tip of my parabola, and now you are ready to tackle some homework with this. Good luck and good